Hi, good morning, good afternoon, depending on where in the world where you are. My name is Paul Roberts. I'm a Senior Principal Solutions Architect here at AWS. And today I'll be presenting along with my friend Irshad on the continuous software delivery using Jenkins, Spinnaker, and Terraform Cloud on Amazon EKS. Irshad, do you want to say a quick hello?
Yeah, thanks, Paul. Hey, good morning, good afternoon, wherever you guys are. My name is Irshad Buchh. I'm based out of Dallas, Texas. Hi to everybody. I'm a Principal Solutions Architect at Amazon Web Services. I've been here for almost 3 years and worked with very large strategic AWS partners on their journey to the cloud. Happy to be here.
Thanks, Irshad, for that. So we're super excited here to talk to you today about continuous software delivery. So we're going to jump into it. And so from an agenda perspective, what Irshad and I thought we would do is we would create a scenario that's going to dovetail into our overall demo. And so the scenario here we'll talk about just for a minute is we have a pet clinic web app. And the idea is that we want to modernize this web app using these open source technologies, such as Terraform, Spinnaker, and Kubernetes, and in this case, it's Amazon EKS. So next, after we set the stage for that, next we're going to do a quick overview on Amazon EKS, and then we're going to drop into an overview on continuous software delivery that helps with this modernization effort, and then finally, we're going to walk through, infrastructure as code and how this is a fully managed SaaS offering with the Terraform Cloud product. And then Irshad's going to walk you through an awesome demo showing you from end to end on how we modernize, our web application. So first thing is jumping into our pet clinic modernization. And here, we actually have, a couple pets that are headlining our website. And this is what the initial website looks like. So the initial pet clinic app here, we have 2 rescue animals. This is, we have a puppy and a kitten here. And, over time, as our pet clinic has evolved, we're continually looking to rescue new animals. And any of you that have pets at home, it's always a wonderful thing to be able to rescue new animals. And in this case, we rescued a new dog, several months back. And here's actually a picture of that dog. And actually, she happens to be my dog that I rescued. Her name is Tilly. She's a white German Shepherd. She's super nice. But going back to our pet clinic app, we want to make sure that we have the latest visuals on that site. So first thing is that our web application, the UI, we need to go through a refresh. And typically, if anyone's done this, if you have to make manual changes, that can be somewhat difficult. So how do we go through and automate some of these processes? And then rolling out software and these changes or even infrastructure changes can be manual. And so as we've alluded to earlier, we're going to talk about leveraging Spinnaker and the Terraform Cloud on how to make this happen. And oftentimes these small medium businesses, they don't necessarily have a huge budget. And in our case, with this scenario, our pet clinic, we don't have a huge budget, so we want to focus on using open source software. This really helps control our costs. And then finally, we've heard and we've learned all about how hyperscale companies like Netflix and Snap are deploying into production at scale, and we really want to be using their technologies and their methodologies. And so we're going to dive in a little bit deeper on about how they do that. And again, the overall theme here for our business is pushing changes to our web application in production can be a bit of a challenge. And so we're going to show you that it's actually much simpler to do that using AWS and various open source technologies. So let's jump into what it looks like to actually modernize the pet clinic application. So first thing here is that we as the pet clinic owners, Irshad and I as the mock pet clinic owners, we decided, Kubernetes sounds really interesting to us, and containerizing our web application seems like a better way to go versus using virtual machines. And the reason is that we really want to focus on the portability that containers offers us, and when we think about, the portability aspect, this is where, we want to look at using something like Kubernetes. And when we looked at using Kubernetes, we said, hey, we could be using Kubernetes directly on Amazon EC2, but we're only a couple guys that are running this business, and the last thing we want to do is manage the operational overhead of maintaining these clusters. So this is where Amazon EKS comes in. Amazon EKS is a fully managed Kubernetes offering from AWS. And this is where where Amazon EKS will fully manage your EC2 instances using managed node groups. So this handles all the patching, the full life cycling of the respective workers. And with Amazon EKS, this is the same as the upstream Kubernetes. We're not forking anything. Everything is identical to what's happening upstream. And what AWS does is we actually manage the control plane on your behalf. And so managing that control plane, what that really means is that we have the API server, we have the etcd instances, and so AWS handles that heavy lifting. And really, it's just up to you or us in the pet clinic example to actually deploy our workloads to these workers that are running within our managed node groups. The other benefit here with Amazon EKS is that you can deploy this across multiple availability zones. So everyone wants to make sure that their applications and web applications are fully resilient. So when we deploy across multiple availability zones, our cluster can sustain outages, which is super important because we want people to continue to be able to adopt pets no matter if there are any outages. So moving on, I want to talk to you about the different components here. And some of these components are what you normally see in customer environments when they're doing their own builds. So number one, Jenkins is probably the most popular continuous integration platform out there. And I would say second, from a continuous delivery perspective, Spinnaker is arguably probably one of the most popular CD tools, open source CD tools as well. So what Jenkins allows you to do, as a developer, I want to do some builds or compilations, or I want to do some tests with my software, or maybe I want to write a custom plugin that does some testing for security tests or scalability tests. So with Jenkins, you can build all that automation into Jenkins and those tests. And what Spinnaker can do is Spinnaker can iterate through a pipeline, this logical pipeline of different steps of what you want to happen during your software delivery or your software deployment lifecycle. So what's great is that I, as a developer, I can say, I'm going to check in some code to my code repository. In this case, we're going to say it's using Git. And once I do that, Spinnaker is going to see that code that has been checked in, and it's going to kick off a pipeline saying, look, we need to go package up this code. We need to place this code. We need to do a build. We need to place this code into a Docker image. We need to push that to our image repository. And then subsequently, we need to be able to deploy that into production. And so automated testing and building and packaging and at scale, it can be kind of complex, but when you combine Jenkins with Spinnaker and Kubernetes, it's just incredibly powerful. So with that, I'm going to pass you over to my friend Irshad, and he's going to dive a little bit deeper into the overall architecture.
Thanks, Paul. Really appreciate it. So, right. So now let's talk about some of the components that Paul laid out as part of this conversation. The first thing that I wanted to focus on is essentially, the Terraform, the infrastructure automation, and then here I wanted to talk about Terraform Cloud. Most of us are aware of the open source Terraform, which we have a lot of community, and then we have been using it for quite a bit of time. We have a lot of partners and customers using open source Terraform. But I wanted to take it to the little bit to a high level, which is the often called Terraform Cloud, which is, think about this as a fully managed infrastructure as code platform, and then it has some of the features that you will see are very valuable for you as an end developer or as a customer. Starting with There's a concept of organization and workspaces. If you're an enterprise, if you're a big company, then within your enterprise, you will have organizations. You may have, different units, vertical units. And then within those vertical units, you will have a number of projects. We call them workspaces. So it becomes very easy for you to scale out these end environments mapping into the individual organizations. The second key thing is, how do you manage the state? Now, for in Terraform Cloud, state management is done automatically for you in cloud, and it's encrypted at rest, meaning, security is a big focus. So you don't have to store. If you're a team of developers, normally, we juggle around storing the state when we use open source Terraform. So here, a lot of that work is done by the Terraform Cloud. And then it has a great user interface where, you will get access to a lot of these different organizations and workspaces, and you manage the infrastructure as code in the form of your source control repositories and tie them into these workspaces. There's also a concept of private module registry, where you'll have access to a lot of modules that are built by you as an enterprise, and then you share those modules across the board with all the organizations. So it's a lot of reuse at scale. And then leveraging GitOps principles, which means that your infrastructure code, which is the HashiCorp configuration files, right? That sits in source control repositories, maybe GitLab or a choice of your own, and then you can integrate those source control systems directly into Terraform Cloud. And anytime you make a change to your infrastructure code, what it will do is you will have an option of running those changes and deploying those changes using GitOps principles. So pretty valuable. And then one other thing I wanted to highlight is the policy as code. There is a option available in Terraform Cloud and Terraform Enterprise, which is Sentinel. Now, what Sentinel does is it gives you the ability of enforcing your governance. For example, you may have a mandate of enforcing tags across the board when you provision resources. Tags is one way of creating resources. You could do wonderful things with tags. For example, you could monitor costs of the different resources using tags. So policy as code using Sentinel will enforce your developers, your end users to use tags, and that there are many other ways of many other advantages of using policy as code Sentinel in production. All right, so I just wanted to spend a few minutes here. This is the workflow, Terraform Cloud workflow. On the left, where you see you as a developer, think about you as you're a part of the infrastructure team, or you're an application developer, and you have access to those private module registries, right? Where you create Terraform modules, or you use Terraform modules available in the registry. And then what happens is that you use your typical IDE, where you start writing Terraform code using those modules. And then you start interacting with Terraform Cloud. There are a number of ways of doing it. You could do through CLI, through user interface. There's a REST API also available. So there are a number of ways how you can actually interact as a developer with Terraform Cloud. And then the state file management, as I mentioned earlier, it's done automatically for you in the cloud. So, and then when you provision the infrastructure, what will happen is, let's say for AWS, you're creating Amazon EKS, which is part of this demo, which is what I have done, or Jenkins, which is running on EC2, the Elastic Compute Cloud Service. So what will happen is then Terraform will provision all of these resources for you. and maintain the state for you in the form of state. It is like a repository for you. So all the developers will have automatic access to that state. So you don't have to juggle between different developer or console machines that normally we do in the open source Terraform world. And then anytime we make a change, what will happen is, as part of the GitOps principles, those changes to your infrastructure code will be picked up by Terraform Cloud, and then those changes will be applied to your infrastructure at scale. All right, so this is the architecture that Paul and I came up with for the demo, and also, the theme of continuous software delivery. Let me go from the left to the right. And by no means this is the only way of visualizing how your different Kubernetes clusters can be architected. This is one way of architecting your infrastructure at scale. So let's start from the left. So we have a IDE called AWS Cloud9. This is your IDE in cloud, and you have your source control. Let's say GitHub will have your infrastructure code as well as your application code. So we're talking about you could have a mechanism of creating different folder structures or different branches. It all depends. There are a number of ways of doing that. And then we have Terraform Cloud to provision the different components that we need. We need Jenkins for continuous integration, which is an open source continuous integration server. And then what we have is when Jenkins builds our code, so we're using enterprise Java for this demo, when it builds those enterprise Java archives, and then ultimately we have Docker files, and we'll have, as part of the continuous integration, we will have a flow where we create those Docker images and then push them into Docker Hub. And then in the middle, what you have is you have a Spinnaker EKS. This is one of the Amazon EKS server or cluster, where all I have is Spinnaker installed and running, which takes care of the continuous delivery. Now, on the right side, what you have is you have two separate clusters. Think about one as the UAT cluster, the terminology that I use. You may have a different nomenclature for it. And then at the bottom, I have the production cluster. So the workflow is when somebody makes these changes on the code on the left as a developer, right? Once the infrastructure is provisioned, and now we're talking about the application code. If for us right now, this is the Spring Pet Clinic application that Paul talked earlier. And if you make any changes, then those changes will be picked up from the source control by Jenkins. It's a as part of the continuous integration. Those changes will be picked up by Jenkins, and Jenkins will run sort of a pipeline. So there's a concept of pipeline in Jenkins, as most of you know. And then as part of the pipeline, what Jenkins will do, it will build, test your code, and ultimately it will create a Docker image which will be stored and pushed into Docker Hub. And once a new tag of that image appears in Docker Hub, what will happen is Spinnaker. In Spinnaker, we have a concept of pipelines as well, which I will show you in the demo. So a pipeline will pick up that new tag of the Docker image, and pipeline will start executing. And it's all automatic. It's like weaved in, and it works from end to end. Now, once a Spinnaker pipeline gets executed, then within the pipeline, Spinnaker pipeline, you will have a number of stages. And I will be using 3 different pipelines for this demo, which I will show you shortly. And what will happen is then the first pipeline will deploy the code changes into UAT cluster. And then you could go into the UAT as a UAT tester or end user and see for yourself those changes. And once you're satisfied, and then you can have a manual process and or approval to go and approve those changes to go from UAT into production cluster. So there is a manual approval pipeline in Spinnaker. Becomes very easy to manage this. And then finally, you will see those changes appearing in the production cluster as well as part of the end-to-end demo. All right, so it's demo time. Let me share my screen, and so that I could show that demo. All right. So let's go through some of the core things that I have. So this is the Jenkins graphical interface you see here, and I have a job. As part of the job, I have some build history, and then there are in different stages that you will see. You have the checkout, the build application, test application, build Docker image, push Docker image, and then some of the other bookkeeping tasks. So that's the Jenkins interface. Now this is in my source control. I talked about the pipeline, the Jenkins pipeline, and this is how we actually codify this. And there are these stages if you can look at. For example, build application, test application, and you can write your stuff, your scripts there. Again, codified once for all. Build Docker image, and then push Docker image into Docker Hub. So, and finally, getting rid of those extra images at the bottom, just to make sure that you don't run out of space. So now all of these are plugged into in the form of a Jenkins pipeline. It becomes very easy for you as an infrastructure, as part of the infrastructure team, when you codify this, because this will be kind of an automatic process. So again, you see those Jenkins pipeline stages laid out very nicely, which I will show you when we trigger some changes. You will see how it typically works. And now let's go to the Spinnaker. So we have 3 pipelines as part of the Spinnaker setup here. We have deploy to UAT, which I talked earlier. And if you look at how it's configured, it gets triggered through that new tag of the Docker image appearing in the Docker Hub. So right now I have configured for a specific Docker image. And then once that gets done, and then we deploy these artifacts using YAML files. Again, this could be in the GitHub. This is in the GitHub right now. There's a petclin.yaml, which contains the definition of the deployment and services. Similarly, there's a deploy to prod. This is another Spinnaker pipeline where we deploy to production. Now this gets triggered by a manual approval process that you see here, which I will show you in a bit. Now what happens is when you approve manually, then the code gets deployed to production. Again, deployment is done through the configuration of the manifest file. This manifest file is in your source control, in your GitHub repository. So these are 2 pipelines. You could create your own architecture. This is just like an example. The third one that I've used is the manual approval. Now, this gets triggered by the deploy to UAT. When source changes, code changes get deployed to UAT, then this manual approval gets triggered. And as part of the manual approval, you have 2 options: approve or reject. Think about you as an administrator. You have 2 options. If you approve, then those changes will get deployed to production. If you reject, those changes will not go to the production. So this is a continuous integration, continuous delivery at scale. Now, also you can get access to the ingress or the load balancer endpoints of the 2 services, which I will show you. It's a good way of getting those links. So I have 2 environments right now running. I have the UAT, which is this one right now. You'll see, and you'll see the old that shape which we want to modify and take it to the next level. That's UAT. And the second tab, you'll see this is the production, right? And again, we have the same image right now. This is how we start. This is where we start. And now we go through the process of the software delivery. How do we do it once we make a change? Because we have to make a change. So let's go back as a developer. This is my Cloud9, and I have the front end page. And then all I'm doing is I'm updating the source code via the new pet image, which is a small change. The concept is to make sure how these changes are incorporated. So I save the change. And then as an end developer, I go back to doing the real stuff, which is like, I commit these changes. There's one change that I see right now. I made these changes into the source control repository, right? Nothing new there. This is parcel of how we work as developers, builders, and the purpose is to show how do we tie all of these pieces together end to end. So when you look at the developer workflow, right now what I'm doing is pushing these changes into source control. So once I have git push, then let's go and watch how these changes will be picked up by Jenkins. Now, Jenkins is right now configured to pick up the changes from my source control repository. And then here you see Jenkins build, a new build gets triggered, right? And the same Jenkins pipeline gets executed, which has got 6 stages. And it becomes very easy to customize these stages, right? This is like one of the examples. I have simple tests. I'm using Maven because we're using enterprise Java. Maven is a good tool to do project management from the perspective of when you're doing enterprise application development using enterprise Java. So you can easily tie in Maven into your Jenkins pipeline. So and testing. I have a simple test here right now just to show the demo, but you can have all sorts of tests included as part of your Jenkins pipelines. So we build a Docker image, and then we push the Docker image into Docker Hub. And so the Jenkins pipeline is executed. And now let's go back into the Spinnaker user interface, where you have to look at all the pipelines that you will see. And what will happen is, because there's a new tag of the Docker image at the Docker Hub, that will be picked up by the Spinnaker pipeline labeled as deploy to UAT, which is like, think about this as like a lower end environment, right? And once that change gets picked up, then here you go. So you will see the Spinnaker pipeline getting triggered. And then you will have a number of stages in the Spinnaker pipelines, right? So it was so quick, obviously, because I have only 2 stages. So it's already deployed. And now it gets dropped into the manual judgment. So I don't want to go directly approve this, but what I want to do first is see whether the new change, that update to the pet app is reflected in my UAT environment. So I go into the UAT environment. This is what it looks like right now. And if I do a refresh at the browser level, you will see that my pet application is modernized, right? Like Paul said earlier, it reflects the change. Now, if you take a look at the production, you will still see production runs the older version because I have not deployed to production yet. I have a tight control using Spinnaker pipelines. Now let's go to the manual approval process, and let's say I'm satisfied as an administrator, and I go in and approve the changes. So what it will do now, it will execute deploy to prod pipeline. That's the pipeline, which is the which is tied in the last piece to the whole end-to-end flow. And it runs pretty quickly. It has got 2 stages, and then ultimately what will happen is those changes will now be automatically rolled into production as well. So from the Spinnaker user interface, you will get access to all of those endpoints. For example, service endpoints and load balancers. So this is the production. Right now, this is what it looks like. Let's do a refresh, and you'll see that the new change is reflected in the production application as well. So this is a demo that illustrates to you how we can deliver software continuously using some of the important tools that we talked about. We talked about some of the open source tools like Jenkins and Spinnaker, and we talked about the managed Kubernetes service, which is Amazon EKS, and how you can tie all of these together to deliver software at scale and codify this, because there is less manual intervention. So there is a chance of chances of errors are reduced substantially, and also it scales well. So depending on how many times you check out code and then work on those features coming directly from your end customers, you can scale extremely well using this methodology. I hope you liked the demo. And at this point, Paul and I are ready to take any questions. If you have any questions around the architecture or around the different technologies that we used today, I'm happy to do that.